Okay. So hello everybody, it's Wednesday. Homework 3 is due right now, and let's go ahead and get started. Okay, so let's do a little bit of a recap. So on Monday, we talked about how to plot lines, functions, and so on, how to plot scatter plots, and overlaying plots on top of one, like one on top of another, on top of a single figure. So that was like all the basics we did on Monday. And I would like to kind of put everybody in a breakout room or something like that. And we could, I don't have any question particularly prepared, but let's say if you had a function, call it sine of x, and you wanted to see how that matched with your data. Let's say you had like a long list of data values or like lists for like X and Y that you imported from the lab, and it was for like the voltage of whatever like circuit you're looking at, and it happened to be supposed to be a sinusoidal curve, and you want to see if it fits with a sinusoidal curve. Maybe like we'll put everybody in 2 breakout rooms, and I want you guys to discuss how would you go about using like plotting to try and figure out whether or not your data actually fits a sine curve or not. So I'm going to go ahead and make the breakout rooms right now. And it should be for like about a couple, or we'll do this for like a couple minutes as usual, and then we will all reconvene. Let's do 2 breakout rooms. Okay, and then we'll open all rooms. I'll see you guys in a few minutes. Okay, so I hope that was useful for you guys to discuss it a little bit. If not, then I hope you had a fun time socializing. Basically, the way you would do it is within the same plot.figure statement and plot.show statement. In between those 2 lines, you would put 2 plot.plot statements, or a plot.plot and a plot.scatter statement, one with the data that you want to put on, like the raw discrete data, and then the other with the continuous function. So hopefully that's what you guys have talked about. If you have any questions, please feel free to ask. Is there any questions? Okay, I didn't think so. So for today, we're going to talk about a bit more advanced plotting. So this is like actually like really cool. I think you're going to like what you see. A lot of stuff can be really, really pretty. That's like one of the best parts about like 3D plots, or we'll talk about 3-dimensional plots and contour plots, stuff you might have seen if you've taken 53 already, or you're taking it right now. We might talk a little bit about histograms and polar graphs if we have time. Probably not. They're not super, super important. It's just kind of like reading a doc and then figuring out what arguments are where. And all of that's outlined in our plotting guide that we talked about on Monday a little bit. We can walk through that a little bit more today. And then we're definitely going to talk about subplots today, because those are super, super important for astronomy and any other physics or like STEM classes you might be need to make plots in. So let's go ahead and get started. Can everybody see the slide still? Good. Okay. So subplots. In order to make plots that look like this, with several different figures or different images in like the same like kind of overall picture, with lots and lots of information, right? This is usually what you see if it's like in an article or in a research paper. It's kind of a lot of work, or I mean a lot of space if you have like one giant plot all over the place, like for everything you want to say. Sometimes you want to condense all your information into one kind of picture. So that's what subplots are good for. And in order to like understand how to use these, we need to understand how they're working a little bit more behind the scenes, because the syntax can get a little confusing if you're seeing it for the first time. So matplotlib likes to, or the way matplotlib works when it makes a plot in general is that it has this kind of background figure. We call it like the figure, and it's you can kind of think of it as like a canvas or like the background of a collage. And then every plot that you make, like plot.plot or whatever, that is simply just like kind of like a little picture on your collage. So In this case, if I have two different plots on the same figure, just think of it as like two pictures on a collage. And you could specify how many of those little tiny plot pictures that you want in your figure. Say you want maybe three, like a grid of 3 by 3, or like 10 by 10 if you're really crazy and you have like lots and lots of data you want, or data you want to show. Maybe it's a 2 by 2. Maybe it's like a really weird layout. You can specify exactly how many spaces you want to make for an actual picture with information on it in your figure. And we call each like mini picture in the figure a subplot. So plot 1 is a subplot, plot 2 is a subplot inside of the main figure. Okay, so there's two approaches to plotting in Matplotlib. And what I mean by two approaches, I mean two different syntax or forms of syntax, and each one kind of has their benefits and their downfalls, or the pros and the cons. So there's the state machine approach, and then there's the object-oriented approach. Now, the state machine approach is what we've shown you a couple days ago. That's like the most basic. You only want to make like one picture. You don't want to worry about lots of different subplots all in this main figure. You just want to like quick and dirty. I have like, I want to plot like a curve or something. I just want to see what it looks like, or plot my data. Just want to know what it looks like. Then you go ahead and use the state machine approach. This is simple plt.figure, plt.plot, plt.show. You're done. Add a title, some X label, Y label if you need, and maybe a little bit more detail, but nothing more than that. It's kind of like the basics. Like that's the state machine approach. You only use it for quick and dirty. It's a lot more cleaner, a lot easier to work with and remember than the object-oriented approach. But it lacks flexibility, specifically flexibility with putting multiple subplots on the same figure. So if you want to make multiple subplots on the same figure, you're going to want to look at the object-oriented approach. You're going to want to remember this syntax. So you use this command. Here, let me get my pointer. Plot or plt.subplots, and then you specify the rows and the number of subplots that you want per row and per column. Kind of thinking of it like a matrix. So 1, 1 is the same exact thing as the statement on the left. 1, 1 literally just makes like a 1 by 1 grid, which is just a plot on the figure. But if it was 2 by 2, then you have like 4 different plots, two on the rows, 2 on the rows, 2 on the columns. And you can work with each one of those different objects. But if you're literally just making one plot, then this is how you would write it. So what this plt.subplots returns is 2 things. One of which is the figure itself, like the figure object, and then the second is the axis object. Now you might be asking, what is an object? So in Python, it's a huge like facet of the way Python works. Object-oriented programming is super important, and it's a big feature of Python. And we'll talk about it a lot more in detail in like several weeks from now, towards the end of the course, when we talk about simulations and stuff. But for right now, all you need to know is that an object has its own functions that are kind of built in to the object itself that work only for that object. We call those methods, and they have traits. So for example, a list in Python is technically an object, just like anything else in Python is an object. A variable is an object. A tuple is an object. They're all objects in this programming language. And each of those objects have different methods or functions that work only for them. So for example, in a list object, .append is literally a function made just for, or a method made just for a list object. You can't use .append on, say, a number, like an integer or string or whatever it may be. It's specific only to the list object. And there's all sorts of different objects, and you can make your own specific objects, like user-defined objects, and we'll talk about that later. But there's the figure object and the axis objects that go inside the figure. So that's kind of the object-oriented approach. Just keep that in mind. Think of, like, back to that image of a collage or like a giant canvas, and each axis object is like the mini plot. So like this would be an axis object. This would be an axis object, specifically axis 1, axis 2, and this is like the fig that we're talking about on this slide. So this is fig, axis, one of the axis objects. There could be several of them. And then when you want to like start working and like adding information onto one of those little boxes, those empty boxes, say ax1, well, it's kind of very, very similar to the state machine approach. The state machine approach. All you do is you do ax.plot and then put the same kind of commands that you would do as plt.plot, but now you're specifying which axis object you want or which plot object you want to put that information on. So ax.plot, you could do ax. The syntax is a little different. So instead of saying like ax.title, you would say ax.set_title. It's like a very minute detail. Usually if it spits out like error for something that you know would work with state machine approach, it's probably just a syntax thing. You can always just Google it, and it'll pop up like immediately. There's lots of documentation on this stuff. But anyway, it's very, very similar from there on. You do your like title and your x-axis and y or y labels and x labels and so on, and you put all that information in that specifically in the form of ax.plot. And notice the similarity to when you use a list and you do .append to a list. Let's say you have a list called, I don't know, stars, right? When you do stars.append, it's the same kind of syntax as ax.append. And that's because ax is an object just like a stars list, or like a list is an object as well, with the whatever comes after the dot being the method or the function that specifically works for that object. Okay, so that's kind of a lot of information. But then at the right at the end, after your whole subplot, like all your subplots in your figure, you do a plt.show. Is there any questions about this? It's kind of a lot of information. Okay. Take it as no. If anybody has any questions, please don't hesitate to ask. So now that we know that, and we know the syntax kind of behind it, there's two different approaches to making figures or plots in matplotlib. The state machine approach is the quick and dirty one. The object-oriented approach is kind of takes a little bit longer to get used to, and it's a little less elegant syntax, but it's more versatile and it helps you create those subplots a lot easier to keep track of everything, for sure. Okay, so let's work with an example. So let's say we make an x and a y, like x being like a linspace between 1 and 10. This is like just an array of like 100 values. And then y is np.sign of x. So remember, this is like kind of treating it as like a continuous line of x values, and you're plugging it into your function y of x, and specifically np.sign of x. So it's the sign function. And then we can just go ahead and do our basic syntax. So figure, or we do our plot.subplots, and then we only want to make one plot this time. So we're only doing 1, 1 here. And we set that equal, or it's going to return 2 objects. So we have to specify 2 variables for it to return to, one of which is the figure object itself, like the actual figure. And then the other is the axis object that you specified. That's where that 1, 1 goes to. It goes straight to the axis object, or it tells it there's only one axis object. You do your x.plot, x.set title, set x label, x set y label. We give it some arbitrary titles, and then it will spit out this, just like as if you did the plt.plot. Same thing. What is going on here? Anyway, so that's just an example. Again, this is in the ultimate plotting guide, so don't worry about it too much, about like memorizing the slide. There's lots of worked out examples on the ultimate plotting guide that'll help you walk through it, because you're going to need to know this for your homework 4. It'll be very, very useful to know how to make subplots for sure. Okay, so that's done. That's kind of all I have to say about subplots. Let's go ahead and start moving into 3D plots. I like 3D plots. I think they're really, really pretty. There's multiple ways to do a 3D plot. The way that I'm going to talk about is kind of like what you see in like a Math 53 textbook, or like multivariable calculus textbook, where it's kind of like an X and Y grid, and then whatever the color values are on your grid determine like how high or how low in the z-axis everything is. So if you have like a color map that says red are really big numbers and blue is really, really low numbers or negative numbers, then it would be like kind of like a pretty color map of like red and blue. It would look nice, depending on what your function is. And the way these 3D plots work, instead of plot.plot, you use a function called plot.imShow. And whatever goes into imShow needs to be like a matrix, basically. So you need to construct a matrix of information that could be, you know, like a bunch of 1s and 0s. If you just want to have like a discrete, it could be like a ton of values. Maybe it's, I don't know, some data from your lab or whatever, or from the CCD that you're looking at, or like the telescope that you're looking at about some star or whatever. And basically you create this matrix of information with the X and Y as your like kind of like a cross array. It's like a 2D array that we talked about a couple or like last week, and we can plot it. So let's go ahead and get started with plotting like a 3D function, like a continuous function, using this. So there's a specific kind of syntax you use if you want to make like continuous X and Y, kind of like the same thing as like a linspace, like np.linspace, but if you want to do it for X and Y and make like a grid, like a mesh grid, but you want to use the like X and Y in terms of like putting it into a function like f of X comma Y, then this is how you do it. So use np.meshGrid and it basically it combines two linspaces. In this case, I say that X goes from -1 to 1 with 100 spaced evenly with 100 steps. And then the y-axis is np.linspace from -2 to 2, 100 evenly spaced steps. And our function's simple. We're just going to say that f is equal to x plus y. Okay, and then so all you do is remember we're doing the state, or for just one plot, I'm just doing the state machine approach. I'm not doing the full object-oriented approach. So it's just the quick and dirty version. You just do a, but you can do it in both. You can use plot.imshow the same way in the object-oriented approach for multiple subfigures. In fact, that's what you're going to be doing in your homework this week. So you do a plot.figure to start to initialize your figure, and then you do a plot.imshow with the function that you're, or like the matrix that you're concerned with. F is technically a matrix because it takes in X and Y and it creates like a 2D array object. That's how NumPy reads it, and that's how the computer's interpreting it. F is a 2D matrix. And then CMap stands for color map. It's kind of like whatever you want to use. In this one, I think I used a color map called Hot. There's tons of different options on the website. I could show all the different colors. They're really, really pretty. They have like hundreds at least of different color maps to choose from. And then origin specifies where you want the origin to be. I think this one I said lower left corner or something like that. There's an example of showing what the origin arguments can be on the Ultimate Plotting Guide. But in this case, that sets the origin down in the bottom left corner. You see a color map from 3 to -3, starting with 0, 0. I'm going all the way up to whatever, like the 100th. I believe this is like the 100th item in the list. It should be technically like if you wanted to be more careful, you can set the X and Y axis labels to appropriately go with the number. Yeah, like appropriately go from -1 to 1 and -2 to 2. But this is just showing like the numbers in there in the array. It's not that important. There's tons of arguments that you can add in, and it's just a simple Google. Anyway, and then the plot.color bar is what's responsible for putting this kind of color bar here to indicate what the different like colors mean on your plot. Any questions about IMShow so far? Okay, so we'll go ahead and move on. So that's how you do like continuous functions in IMShow or in like 3D Python or matplotlib. But let's go ahead and let's actually work with like a data file, right? We learned about np.loadText the other day. So let's go ahead and put that to use. So let's say we have like a data file. I called it data file, and it happens to be a CSV file. It could be a .text file. It could be any file really, as long as loadText supports that file type and you know how to work with that file type. My favorite is the CSV because everything's spaced out by a comma. So I just set delimiter equal to a comma, like a string of a comma, and that tells the loadText function, hey, anytime there's a comma, I want you to basically make that like the cutoff for whatever data is in between those two values. So it reads 1, comma, cut, that's the next 0, or the 0 is going to be the next item in the array, comma, 1 is going to be the next item in the array, so on, so on, so on, so on. And it'll unpack it. I set unpack actually equal to false. So what that does is that makes sure that every column in your data is not transferred to a separate variable as like a 1D array, because unpack equals to true means that this entire column, if you had like, I think I have 3, 6, 7, 8, I would need 8 variables to specify that or to save each one of these, or 8 different columns. That's what unpack equals true. It takes this entire column and assigns it to a assigned variable. But you have to make sure you account for that. So you have to put 8 different things here, 8 different names for each to keep track of each different column. But I don't want to do that. I want to keep the entire thing just as like a 2D array, the way it should be. So then I set unpack equal to false, and that all goes in my np.load text statement. And I save that as a variable. I call that checkerboard data. And that checkerboard data is a matrix. It's a 2D NumPy array. Okay. And then I just do my simple plot.figure. Fig size is set equal to 1212, so it's nice and big. And then I am show. We do the good old stuff. And I made like a checkerboard when you go to plot it with your IM show. This is what this data file will read in here. I can't remember what color map I use. I can't remember, but basically it's black on one spectrum or one side of the spectrum and white on the other. And since they're just zeros and ones, it just, 0 is the minimum, black is the maximum. Or my bad, black is the minimum, white is the maximum. But that's not important. Anyway, that's how you load in a specifically like a 2D array from like a text file or a CSV file, and you can plot it. And here's just a couple examples of some really, really pretty plots. There's some fractals here. I believe I took this from EPS 109's website, maybe. And then like here's like some actual data that we plotted, or that I've plotted before for like an image of silicon, like its actual surface, which is pretty cool. And here's like just some crazy multivariable function with like a conform map or something like that. But is there any questions about 3D plotting? Because if not, then I'm just going to go straight into a demo. So I have some pretty interesting demos. Okay. If there's nobody that has any questions, then we'll just go ahead and move on to demos. Monday, I didn't have any good demos, and I was like really bummed out about that. I wanted to make sure I actually had something interesting. So here, let me go ahead and open up a Jupyter Notebook, and we'll get started. Give me 1 second. Let's do, where is everything? There it is. Computer's like super laggy. Window. Do a new. And I apologize. My computer is super laggy. There we go. There it is. Can everybody see this terminal? Good. Okay. Sorry about that. Let's go ahead and move into where everything is. Let's go ahead and move to Jupyter Notebook. Or open up Jupyter Notebook. It should pop up. There we go. So everybody can see the Jupyter Notebook, right? Or like my mouse and everything, my files. Good. Okay. So let's go ahead and go to demos. We'll make a new file. And we'll just go ahead and get started right to work. So let's go ahead and start with the basics. Import NumPy, do our nice little preamble. This last statement is not super important. It's just I'm gonna make a custom color map. So that's what this last line is for. So let's go ahead and start with this example. So let's do an actual coding example of making the mesh grid and like doing like a continuous function. So let's go ahead and say x comma y. We'll set those equal to np.meshGrid. Couple in spaces. We'll set these from, I don't know, like -10 to 10. And that's a lot. So I'm gonna put 1,000 data points, and then we'll make a second lin space for the y coordinates, and that'll also go from 10 to 10. Yeah, so that'll be our x and y, and then we need to calculate an f, or we need to have a function. So let's just do like some sine functions. We'll set np.sine of x plus, we could do like, I don't know, np.sine of -y. That would be kind of fun. And then we'll just go ahead and make a figure. We'll set plot.figure. I'm just doing the state machine approach, and then I'm going to set the figure size, and we'll make it like 12, make it like a nice big old square to look at. And then we can do plot.imShow, and I'm literally just going to plug in an F. And I guess I should specify my color map. So let's just set CMap equal to, I think there's one called Jet. You know, it's kind of pretty. And then we can do plot.colorBar here, and then can't forget my plot.show. And what that's going to do, it should spit out, yeah, oh, it's kind of pretty. Nice little pretty sine of, I think it's like sine of x plus negative sine of, or sine of negative y. So the dark blue corresponds to like negative numbers, and then the like dark red corresponds to the positive numbers, and it goes from -2 to +2. And I don't know, it looks kind of pretty. I think it looks nice. And then let's do an actual example of working with data. So let's go ahead and do like np.loadText. Again, and we'll import a data array. So I have like a data file kind of already made, and I think it's called this. It's a CSV file, so I'm setting my delimiter equal to like a comma. But if this was a text file, you don't even need to specify what the delimiter is. And then since I want to keep it as an actual like 2D array, then I set unpack equal to false. It's important to remember that. So that's our data. And then I'm going to make a custom color map just because I remember what it is what the data file is, and I want to make sure it looks good. So you could really ignore this part. This is like not even important. It's more for show. But if you wanted to be a real overachiever, you can make your own custom color maps, but super not important. There's plenty of them to choose from. They just didn't happen to have one that's specifically the one that I wanted, so I made my own. And then I'm going to set the figure size equal to like a nice big old box, 1212. And I'm just going to do plot.imShow as usual, because I want just one figure, or like one plot in the figure, so I don't need to do anything crazy. So I set custom CMap equal to, like, this is like a color map. I just put it as that variable, and I put it in there. There we go. And then, I don't know. Oh yeah, and I can't forget my plot.show. I don't bother with titles or anything. Yeah, there we go. That's kind of neat. You can import some data. I made a creeper head. I don't know. I thought that was kind of nice. So that's that. And then there's one last example that I want to show you. So like, what if you had like a data file from, I don't know, from the internet? Maybe it's from a telescope. You know, I happened to download a data file from NASA, for example. You can actually find it on their website. They have lots of different data files. Astronomers tend to use a data file type called a FITS file. We'll talk more about that in a couple weeks. Not super important that you know what a FITS file is right at this moment. Just know that it encodes a lot of information, and you can take out kind of like a 2D array out of it. So let's go ahead and do that, and we'll get like a nice astronomy object, because after all, this is for the astronomy Python decal, right? So let's go ahead and do that. So I'm gonna import some stuff. Don't worry about this. This is like something like a library called AstroPy. We'll talk a lot more about it in the next coming weeks. But for right now, I'm just gonna use it to get some data or to open up a data file that is really hard to work with in any other format other than like this AstroPy data file. So I'm importing this image data. It's like some command like this, get data, and then it's like I have it saved in here. I have the path file saved, so I'm just going to copy that right over here. It's kind of neat. So I have like a FITS file of like some astronomical object, and I happen to know that it needs to be rotated, so I'm just going to use some library to rotate it. Not important. It's just data. Yeah, it's like, there we go. Yeah, and then now that so that gives me my data. Oh, I should probably zoom in. I haven't seen the chat. Yeah, sorry about that. Can everybody see that better? I think that should be better for those in the chat. I have it open now, so please let me know if it needs to be zoomed in more. But anyway, just importing an image from like a file. It's not super important. That image data is like a 2D array, and I'm just rotating it because, well, I just happen to know it's sideways when the way I downloaded it. So now it's just a 2D array, and I'm just going to plot it. So it's like a weird shape. So let's do, it's like this, I think. And then we should plot the IMShow. And I'm going to put the rotated image in there. And I'm going to set this is probably my favorite color map. I'm going to set it equal to Inferno. That's like the coolest one, hands down. It's like either that one or hot. And then I'm going to specify some information about the color bars. You'll see what it means in a second as soon as I get this plotted. I'm going to do like plot.color bar and plot.show. This should work. Oh, import from, yeah, that's why. Oops, there we go. Cool. So this is the data file that I happen to have. It's the Sombrero Galaxy. Might have been hinted from the sombrero.fits. But anyway, so astronomers use like these data files, .fits files. Don't worry about it. We'll talk about it a lot more in the next couple of weeks. But anyway, I just take their data, I put it in a 2D array. I downloaded the 2D array onto my notebook in the form of this image data. I rotated it using some library that's not important by 180 degrees. And then I just plotted it. And you'll notice what these vmin and vmax do. They just set your color bar max and min to a specific number. So I happen to remember that like it needed to be 6,000 and like 23,000. And if it's anything else, it kind of shifts it either shifts how saturated or unsaturated it looks. So let's say, for example, if I set the maximum equal to like 10,000, it'll look a bit different. Give it a second. See, it's like super overexposed. So I just played around with that until I found the right one. So it's not super important, but I think it was like 23,000. Similarly, if I raise the minimum up too high, then it's just like all dark and you can't see any of the background. So I thought this was like the nice little sweet spot. It's pretty, it might need to actually be like 21,000. Can't remember exactly where I had it. Yeah. Set that 21,000. And then just for giggles and stuff, let's do it again, except we'll do it for a different image I happen to have, just because I think it'd be kind of pretty. I thought this one was super pretty. I think this one's called, I can't remember what I called this one. Is it? I believe that's what I called it. Yeah. And then I believe I rotated it by 270 degrees because it was that way. And then min is 0 and the max is 400. Okay. So I'm just changing the color bars and everything. But yeah, so this is the Eagle Nebula. This just happened to be another data file I had. Used the same exact technique where you just plot. It's like literally just a bunch of information. There happened to be nothing available in like all of this region here with like the black squares. So it just kind of plots a black or plot black with 0 count. But anyway, like all of this information is really pretty. Yeah, so that's taken like directly off of NASA's website. And if you're curious on like how to work with these data files, stay tuned. We'll talk about it in like a couple weeks or something like that. Yeah. So is there any questions about any of this? Okay, just a little recap of what we did, right? We can plot 3D functions with like continuously using like a np.mesh grid with 2 different lens spaces inside of it. That gives you your x and y. You can use it inside of a function, and then you can plot that function. It like encodes it as a 2D matrix, and you can just plot it. CMAP means color jet. IM-show is how you plot functions like this. There's another way to plot functions that's like an actual 3D grid that looks like this. I don't particularly like using that because it's kind of hard to look at. It's not as pretty, especially if like the function is like really cluttered. There's a lot of information. Only some things look really nice in that. But we'll talk more about that when we get into animation later. But anyway, so that's that. You can load as you can use np.load text to load a data file as an array, a 2D array. Maybe you happen to have some data, you could plot it like so. You can make your own custom color maps. It's not super important to know how to do that. I've literally only used it just for this one example because I wanted to make a creeper. I couldn't find anything that goes from black to green, so I just did this. And then astronomers use data files like this very similar to what we were talking about. They're just a little bit more complicated, and they have a lot more information in them. So you got to use a little bit of a different syntax and stuff, or a different library to open them up the same way. Not super important. We'll talk more about that later. But you can take the information out from like a telescope in a FITS file, and you can put it as a 2D array, and you can plot it just the same way as we've done everything else. You get some really pretty stuff. So there's that. And then I just want to remind you, homework 4 is posted today. If you need help on it, please come to office hours. Use the Matplotlib ultimate guide I supplied to everybody. It will help you greatly with this week's problem set, specifically all of the plotting stuff. Like there's lots of examples there to help you and guide you. Last year, a lot of students like completely like dropped the ball on this homework, and particularly because they got overwhelmed. So please come to office hours if you need it. Yeah, I mean, that's all I have for today. We're a few minutes short, but I think that's a good thing, especially on a Wednesday. So yeah, everybody's free to go. If you have any questions, stick around, but thank you for coming, and I hope everybody has a good day.
Thank you.
Thank you.
Derek, Asher, Alondra, sorry. Do you guys have any questions?
I had a question, but I'll wait till everybody else goes because I just wanted to clarify something on the homework. But
Oh, okay.
I was just trying to type thank you in the dark. Thank you.
Oh, no problem. Alondra, do you have any questions? Oh, yeah. I gotta stop recording.